Hey guys, welcome to Stat 441, the online course at Virginia Commonwealth University. This is part 4 for the lectures on Chapter 2, Descriptive Statistics. In this lecture, we will learn about some methods of, some measures of relative standing. Okay, so what we have seen so far, we have seen some numerical measures to describe the center and to understand the spread of the distribution of a quantitative data set. In addition to that, we might also want to learn about the location of an observation with respect to other values in the distribution. So we will learn about two measures of relative standing. The first one is the percentile, and the second method is z-scores. First, let's talk about percentiles. Let's say we have 100 times pth percentile, let's say we have a 95th percentile value in a data set, that means that below that value, we will have 95% of the distribution, and above that value, we will have 5% of the distribution. So basically, P is between 0 and 1, and 100 times P will be the percentile. Here's another example. Let's say your grade in an industrial engineering class is located at the 84th percentile. That means 84% of the grades are lower than your grade, and 16% of the grades are higher. Okay. These are some commonly used percentile values. The first one is a 25th percentile. It is also called a lower quartile. The notation is QL. Then 50th percentile is also the median or the mid quartile, denoted by the letter M. 75th percentile is the upper quartile, or QU, for the data set. Okay. In general, if we want to find the pth percentile, we can calculate the quantity I, which is P times N plus 1 divided by 100, where N is the number of observations, P is the percentile, and then I will give us basically the observation if we have arranged it in the increasing order. Okay, let's look at an example. A team of engineers conducted several experiments to measure the freckle index of certain type of superalloy. The data for 18 alloy tests is shown. It's on the next slide. Create a stem and leaf display for the data and use it to find the lower quartile for the 18 freckle indexes. Okay, so here's the data set. We have 18 observations. We can make a stem and leaf plot here. As you can see, these are the values displayed here on the stem and leaf plot. Now, to find the lower quartile, we know lower quartile is the 25th percentile. So in this case, N is 18, okay, and then this is 1/4. So 1/4 times N plus 1. So P is 1/4 or 0.25. When we calculate this, it gives us 4.75. Round it, so L is 5. So the fifth ordered observation is the lower quartile. So if we arrange our data set in increasing order, that's what we have done in the stem and leaf plot. So the fifth observation is the lower quartile, or QL. In this case, its value is 4.1. Okay, here is the next measure of relative standing. It's called the z-score. So when we find the z-score of a value y in a data set, what we are trying to do is we are trying to find how far is this observation from the mean in units of standard deviation. So is it 1 standard deviation away from the mean? Is it 1.2 standard deviation away from the mean? If it's less than the mean, then the z-score value will be negative. So when I say the z-score is negative 1.5, that means it is 1.5 standard deviations away from the mean on the left hand side. Okay, so it's a very simple calculation. For a sample, the z-score value can be calculated as y minus y bar divided by s, which is the standard deviation. If we are calculating the population z-score, then z is equal to y minus mu divided by sigma, where mu is the population mean, sigma is the population standard deviation. Okay, here is an example. Let's say we have a data set which is percentage iron content for 390 iron specimen. Find and interpret the z-score for the measurement of 66.56%. Okay, so for this data set, we have the summary analysis. The mean is 65.74 with a standard deviation of 0.69. We are trying to figure out what is the z-score of 66.56. This is one of the measurements. Okay, so to find the z-score, we need the mean and the standard deviation. Sample mean is 65.74. Sample standard deviation is 0.69. So the z-score is y minus y bar divided by the standard deviation. Y is the observation. This is the mean and the standard deviation. So 1.19 is the z-score. What does that mean? It means that this observation of 66.56% lies at a distance of 1.19 standard deviation, which is to the right of the sample mean, which is 65.74%. Okay, now once we have figured out the relative standing of an observation, another thing that we want to understand in a data set is to see if there are any observations which are unusually large or small relative to the other values in the data set. So these observations which are unusually large or small are also called outliers. So typically, there will be outliers in a data set due to one of these reasons. First is that the measurements that were observed or recorded or entered incorrectly. Okay, so that's a possibility that the measurement was 100 and there was an extra zero, so that makes it extremely large. The other possibility that the measurement came from a different population, so it's incorrect. And the third is when the measurement is correct and it is due to a rare event, that this observation is very large or very small with respect to the other observations. Okay, now we want to figure out if there are any observations that are outliers in a data set. And the most commonly used method is the z-score method to detect outliers. So let's see how we can use the z-score to figure out if a particular observation, if it's an outlier or not. Okay, so let's look at an example here. So one of the data sets we used earlier, it was energy-related accidents worldwide since 1979, which resulted in multiple fatalities. So we looked at the causes of the accidents. Now let's say there was also information on the number of fatalities for each accident. And one of the observations is a dam failure accident that occurred in 1979, killing 2,500 people. And based on the rest of the data set, we want to figure out if this observation is an outlier. Okay, so we need some descriptive statistics for the rest of the data. So there were 62 observations. The mean was 208.3, standard deviation 344.6. Okay, so based on this, let's calculate the z-score value for our observation of 2,500. So y minus y bar divided by s gives us the z-score. In this case, 2500 minus 208.3 divided by 344.6, which gives us 6.65 as the z-score. Now, if you recall, the empirical rule says that all the observations would be within 3 standard deviations of the mean. And even if we use the Chevyshev's rule, it guarantees that at most 11% of the observations will be outside that 3 standard deviation range. In this case, the z-score is 6.65, which is really large and which indicates that 2500 is an outlier. It's an extreme observation, and most of the observations will be within 3 standard deviations, or the z-score will be between -3 and 3. So this is an outlier. Here is the rule that we can use. So if the z-score value is, if the absolute of the z-score value is between 2 and 3, so it could be on either side, negative or positive, then it's a suspected outlier. But if the z-score value is, absolute value of the z-score is greater than 3, then we can highly suspect that it is an outlier. Okay. Another method to detect outliers is box plot. So box plot is a graph that we make, and then we can figure out based on that if we have any outliers. So first, to make a box plot, we need to calculate a quantity which is called the IQR, or interquartile range. It is the difference between the upper quartile and the lower quartile. Remember the 75th and the 25th percentile values. So that gives us the IQR. Okay. Then to make the box plot, this is what we do. We start by making a rectangle here. The top of the rectangle is the upper quartile. This is the lower quartile, the bottom one. And in the middle is the median value. So that makes the box in the middle. Okay. Then we mark the points 1.5 IQR on each side. So this is called the lower fence, which is QL minus 1.5 IQR. On the upper side, this point is called the upper fence, which is the upper inner fence, which is the QU plus 1.5 IQR. Okay. Then we make another pair of fences, which is at 3 times IQR. So this is the lower outer fence and the upper outer fence. So QL minus 3 times IQR and QU plus 3 times IQR. So this gives us the 2 fences. So this is what a typical box plot looks like. So what happens is any measurements which fall outside the upper inner fence and the lower inner fence are suspected outliers. Any values which are outside the outer fences are definitely outliers. So we can compare these values to figure out if we have any outliers in the data. Okay, for the box plot, these are the rules. Suspect outliers, any data points between the inner and the outer fences, and highly suspect outliers, data points beyond the outer fences. Okay, here's a quick summary. Both methods, the z-score and box plot method, can be used to identify outliers. Both should give similar results, except in the cases when there are a lot of outliers in the data set. In that case, the value of the standard deviation would be inflated, which in turn could impact the z-score value. But the other method, the box plot, it doesn't get impacted by outliers. So these are the measures of relative standing. Thanks for watching this video, and look for the next video for probability. Thank you.